Hello, good morning, everyone, and welcome and thank you for attending today. My name is Steve Cruin, and I am the National Sales Manager of Midland Technologies, based in the Minneapolis-St. Paul metro area. We're pleased to present this series of webinars Midland has developed. These webinars are focusing on high-pressure die casting. Midland, along with its sister companies, are all part of Innovant, a 100% employee-owned organization. As owners, we are all dedicated to providing our customers with the highest level of quality products and customer service. I would like to introduce the following presenters for this webinar. Our main presenter for this webinar will be Mark Steen, General Manager of Midland Technologies, and he's been with the company for almost 2 years now. For the past 25 years, Mark has held management roles at companies in a variety of industries. Most recently, he has held a variety of senior leadership roles over 10 years at an electronics manufacturer based in the Minneapolis area. We also have Larry Winkler, who is president and owner of Owintech Inc. Die Casting Consulting. In '96, Larry developed and implemented vacuum assistance in chill blocks and die casting, and a year later, working with Midland Technologies, commercialized the product. Larry has over 35 years in the die casting industry at 5 die casting companies in a variety of engineering roles. Our final and last panelist here is Bill Zabracki, who is our engineering manager here at Midland Technologies, where he designs and coordinates all engineering activities. He has 30 plus years in the manufacturing industry, ranging from electromechanical circuit board test units, hydrostatic high pressure valves and pump systems, and now high pressure die casting components with an emphasis in designing, managing, operations, and quality control. If anyone has any questions, please submit your questions via the chat feature, and then we will get to those at the end of the presentation here. Thank you again, and I will now hand it over to Mark Steen.
Thanks, Steve. And thanks again, everyone, for joining us today. I'm going to jump right into the presentation. And the first thing that I wanted to cover is why Vac-Alert. Why did we come up or develop the product? Through a lot of discussion with our customers, we had heard that there were people that had brought up issues with our valveless vacuum blocks, and really just valveless vacuum blocks in general, no matter who the manufacturer is, where there is a tendency over time for carbon and aluminum oxide to build up in the blocks, and that creates proper airflow issues. And over time, that buildup eventually gets to a point where the vacuum level within the cavity is compromised, and it starts creating porosity issues within the components. And the main reason for utilizing vacuum is to reduce porosity. So with that, the customers asked us, hey, is there any way to solve this problem? And after looking at it, we thought of maybe a couple of different routes to go, and that led us to developing the Vac-Alert system. So there's a diagram off to the right, and it's a hardware-software system combined with transducers or vacuum sensors to monitor the vacuum system from end to end, essentially all the way out at the tool and feeding back to the vacuum pump on the other side. And Vac-Alert, and the key to it is it can detect the vacuum level in the die cavity in real time. And the other benefit is that it monitors key components and alerts you of situations before maintenance is needed. So it helps to troubleshoot and narrow down where a potential clog or issue is within the vacuum system. And again, the other thing is it also alerts the operator when the vacuum level is too low, and that's through the HMI system. The nice thing about our product is that you can use your own vacuum pump, whether it's a central vacuum pump or a vacuum pump at each cell that you're utilizing vacuum on for die cast machines. So here's a larger diagram of the Vac-Alert system, and it shows the sensors all feeding back to the HMI, and again, out at the actual tool itself. And here is the eye block, which is the heart of our system, and I'll get into that in a little more detail. But so how does the system work? Well, this is the main page of the Vac-Alert touchscreen display, and it shows the vacuum level at each one of the sensors right before fast shot. So you can adjust Vac-Alert to set up and take a snapshot, and that's essentially what this is a snapshot of the vacuum level, and preferably you'll want to have that configured and set up to happen right prior to fast shot so that you know what the maximum vacuum level is in the tool before the aluminum is injected into it. The nice thing about our transducers that we have as a part of the system is that it will measure the vacuum level at every 20 millisecond intervals. So 50 times every second, it is sampling the vacuum level at each one of those sensors. And here is data from a customer site during some initial testing that we had done. And I'll kind of walk through this. These four lines right here represent sensors that are both at our filters as well as at the blocks within a tool. And the darker blue line down here is a sensor measuring the vacuum level right before the solenoid valve, essentially monitoring the vacuum level in the pump. So once the solenoid valve opens, you see a loss of vacuum level within the pump, but that correlates with a drop in vacuum at all the other components in the system. So as air is being drawn out of the entire vacuum system from the solenoid valve all the way out to the tool, you can see this drop in vacuum to a point where a little over a half a second into the valve being open, we've got about 75% of the air removed, and it continues down, and right before fast shot, which is right here, you know, we're down in the maybe 27 inches of mercury level, somewhere in that neighborhood. So that led us to further validation that this is a good course to take. And we started doing some additional evaluation and thought, hey, well, what if we install an additional block that is just measuring vacuum level within the cavity, and what kind of value would that add? So this is a piece of data where we added that eye block to measure the vacuum level within the cavity itself. Again, the same principle. Here are all of the other components in the vacuum system, and then this one is measuring specifically the vacuum level within the cavity. Now I'm going to go to the next slide, and you'll notice a very subtle difference in the curves right in this area, but you're going to see a significant change in the eye block. It's going to be up much higher. And what we did in this scenario was we blocked off or restricted the airflow for the valveless vacuum blocks, representing a clog in the blocks to show what would happen and what the eye block would measure. So as you can see here, there's a significant drop in the vacuum level within that cavity itself, and there was such a subtle change right here within these vacuum curves, but they much more quickly drop down to a near perfect vacuum. And I'll just kind of go through those again and just toggle between them. So recognizing this, we realized that the eye block is really the critical piece in the puzzle that will help die casters know what that level is within the cavity. And so we kept going down the path of developing our system with this additional block that utilizes a transducer at the top of it. In addition to that, one of the other features of the Vac-Alert system is the ability to go backwards by individual shots or by 10, 100, or 500, so that you can see the evolution of these curves over a period of time, whether it's a couple of hours or a shift or multiple shifts or even days. You can set this up and click on the day button, and it will allow you to select other days that you may be running that exact same part, so that you can see how this eye block is performing, so that as you see this start creeping up, you can stop everything and evaluate whether there's any buildup on the block itself, or maybe within the different filter system or other places within the vacuum system, to do some preventive maintenance and do it at the appropriate time, rather than doing preventive maintenance too frequently, or worse, too infrequently, and therefore creating bad parts. The other nice thing with this statistics page within the Vac-Alert system is it allows you to also download specific shots onto a USB drive, so you can put it into an Excel spreadsheet and do further analysis. So the eye block is the heart of our system, and here it's designed into a runner system, but you could have it designed into right into the side of a tool or into the cavity itself to measure that air. And again, it measures the vacuum level during the casting process. And if the vacuum level falls below a certain level, you can utilize the Vac-Alert system to warn you or alert you of levels that reach a point where you're still making good parts, but it's getting closer and closer to a point where vacuum level falls low enough that you're going to see porosity and significant porosity issues. Our next software release is also going to have the ability to shut the machine down at the end of the cycle if the vacuum level falls below or falls into a red zone. Again, that red zone is something that's adjustable by the user to whatever inches of mercury or negative PSI or however you want to set it up within the system. But again, here's a closer look at the eye block. It is what Midland refers to as our mini block. So it's the smallest block in our family of valveless vacuum blocks. And we did a great deal of testing to validate that we can indeed use that smallest block for majority of applications. So the system's easy to program. So here are a few screens within the Vac-Alert system. This allows you to set up all the sensors that are necessary. So depending on the size of the tool or the complexity of the tool, you may have only a single block or you may have multiple blocks. And in addition to that, you can turn on a semaphore. And on this page over here, you're setting up the vacuum period. So whether that vacuum cycle is 3 seconds long, 4 seconds, 2.5 seconds, you select that over here and select the shot multiple. We're suggesting that everybody monitor each individual shot so that you can get all those individual graphs for them. And you're up and running. And programming takes about 15 minutes to set all of the parameters. So what's included with the Vac-Alert system? So again, it's the HMI, the filters, and sensors that go with the filters, 24-volt DC solenoid valve, and then the cable harnesses necessary to connect back up to the Vac-Alert system. There are other components. The eye block, and this is a closer picture of the eye block. So again, sensor at the top of it, measuring vacuum being pulled out of the tool. Sensor blocks, and here are the Midland valveless vacuum blocks with the sensors built into them. A light tower is an option, along with mounting systems for both our filter system as well as the HMI. And a variety of AC and DC relay interfaces to interface with your high pressure die casting machine to initiate and stop the opening and closing of the valve and capturing the data within the Vac-Alert system. And again, we even though you can use your own central vacuum pump or pumps that you may have at individual cells, but if you don't have a vacuum pump, we do offer those as well for purchase. So some of the product features for Vac-Alert, we do have a USB port for both software updates as well as downloading the data, as I had mentioned earlier. A network connection, Ethernet or wireless connectivity to obtain accurate date and time information for Vac-Alert. And some of the features that are under consideration in the future for the system is email notifications and or text notifications to alert people as, again, the system moves from a good to a caution to a red or problematic vacuum levels within the system, and as well as potentially remote monitoring from another area within the plant if you have multiple Vac-Alert systems. Maybe there's a quality or process engineer that would like to see this at his or her desk. The system is built for high pressure die casting environments, so it's a heavy duty welded enclosure with both Amphenol and Harding connectors, insulated heat resistant cable harness, and high temp tolerant vacuum sensors. And this is shown with an optional bracket for the wall mount arm. And again, this is just sort of a standard computer monitor configuration in terms of the dimensions here. So whether it's hour mounts or any mount that you can find at a local electronics store, anything will work in a situation like that. So as I mentioned earlier, there are notifications, and these parameters for good to okay to bad vacuum levels can be user adjusted on a per sensor basis. And if the level gets into, let's say, the yellow zone, there will be an indicator showing off to the side of that particular sensor warning you of an issue. And this one is in the red, and so there's a red box over to the side. So these are some of the visual indicators that we provide on the touchscreen itself. And in addition to that, we also are going to offer a couple of different light towers, one with an audible alarm, and this is that one, and the alarm is, the equivalent of like a smoke detector in terms of both volume and the type of noise that it emits. And then we just have a basic red, yellow, green light tower as well. And again, a future update that we're looking at for the system is machine shutdown at the end of the cycle when the vacuum level is too low in the cavity. So if the I block, which again is the critical one, reaches a level where it goes into the red zone, that could be initiated within our software to shut the machine down at the end of the cycle so that you can't make any additional parts that could be bad. So again, that helps to reduce any potential for scrap. Again, future upgrades that we're also looking at, a humidity sensor within the die cavity itself, possibly a temperature of air exiting the tool, that both may factor into the quality of parts. Again, as I mentioned earlier, notifications and the low vacuum, meaning machine, equals machine shutdown. But again, that list is going to be prioritized based upon our customers' greatest needs. So as we get feedback from customers that do implement Vac-Alert, we'll be evaluating those and prioritize them accordingly. So here is a demo of the system in operation here, and I'll play this again, but this is showing the different graphs or, scrolling through a variety shots that were captured with Vac-Alert. And I'll play it again. And at the very top, keep an eye on the graph over here. It's going to show you a transition from one shot to the next, because the number will change on the graph for that particular sensor, and really all of them. So again, I'll play it a second time. So it went from 1295 to 746, and again, it'll go through the rest of those. So at the end of every cycle where the solenoid valve closes, that snapshot that you adjust and set up to capture the data for the main screen, whatever you set that setting at, whether it's 2.5 seconds into the vacuum cycle, or 3, or 2, it will capture and snapshot what the vacuum level is at that particular time. So again, that's the key part of the system. If you're interested in testing, we do have a couple of demo units that will be available in early June, and feel free to send an email to info@Midland Technologies, or feel free to contact me at the phone numbers listed above as well, and we'd be happy to talk with you about the things that we would need in order to move forward with the testing. I also wanted to give you a little bit of a background. Again, Steve had mentioned earlier that we're a part of a larger organization that is an employee stock ownership program. We do have 2 companies that are sister companies of ours, and one is Elmco, and I know there are a lot of die casters out in the world that are doing secondary operations within their plants, and Elmco does offer vibratory finishing equipment and industrial parts washers, and can do full custom equipment design based upon customers' needs. And then we also have Mass Finishing, another sister company of ours that does high-speed deburring and polishing equipment, and there are a couple of examples of before and after photos of parts that they have polished. Both of the companies do offer a lab, so that if customers of theirs have parts and are not exactly sure how to, or what's the formula and the time needed to do the deburring, they're happy to help with that, on a case-by-case basis at no additional charge. But again, just wanted to bring up those 2 in case anybody's interested. We would be happy to make an introduction to those 2 sister companies. So, questions from the audience related to Vac-Alert. Like Steve had mentioned earlier, feel free to type any in, and I think you have a couple.
Yeah, we've had a few viewers submit some questions here. So the first one that I have is, and I know some of these you touched on briefly during the presentation, but so they might be a little redundant, but we'll recover them. Is this one system that can be connected to multiple machines to monitor all at the same time, in one place?
Mm-hmm. Yeah, the current Vac-Alert system that I showed you is a one-to-one system, where that Vac-Alert system is connected directly to a high-pressure die casting machine. Again, this is our initial product that we've developed. That may be something that we would look at in the future, but again, this is one-to-one. You can, though, move it from machine to machine. So if you wanted to put it on, let's say, a portable cart and roll it from one location to another, you could do that very easily. And that's an option as well.
Perfect. And then, how many readings could be stored on the Vac-Alert system?
Thousands can be stored. There's a 4 gig limit to the data that is on the system. So I would say every week, maybe week and a half, you'd want to purge the data out of it. But again, it can do tens of thousands of shots, and we've done that within our plant here as well.
Perfect. Now I have a question here for Larry and Bill. In your experience, what is the expected benefit, when talking about scrap reduction and efficiency and using a vacuum system? And I know you've touched, on it before in some past webinars, but if you maybe want to go into that in a little detail.
Right. Yeah. Good question.
Sure, Bill.
Well, first of all, with using vacuum, you're introducing another source to take that gas out, and so it benefits yourself with compared to the conventional venting, and that helps with also helps with reducing your scrap as far as scrap for your final product. We have found many cases where there's quite the decrease in scrap percentage-wise with different customers of ours once they start using vacuum. So it's again you have to think about it. When you're pushing the metal through without vacuum, all you're relying is the metal to push the gas out. But with vacuum, you're introducing another source to extract that gas, and that's certainly beneficial. And Larry, if you got more on that.
Yeah, it reduces the amount of scrap, as you mentioned, and reduces the porosity, improves both surface quality and internal quality of the castings, so which are beneficial compared to, as you mentioned, Bill, compared to venting, which is a push method of removing gas.
Great. Thank you, guys. Right now, I'm not seeing any other questions. I'm going to give a few minutes to allow any other attendees to submit anything that they might have. I'm going to take a quick moment here to announce our next webinar, which is going to be cooling options for high pressure die casting. The date on that is going to be June 23rd, and if you haven't seen an invitation for that, expect to see one shortly here. Looks like I do have another question here come in. This one might be for between Barry, Larry, Bill, and Mark. Sorry, we got a little tongue-tied here. A joint question, but what is the allowable leakage limit on the tool? It might be more for Larry and Bill. I'm sure this is kind of, if you want to go into that a little bit.
Yeah, I guess I could address that one. Well, first off, we through experience have determined that the most likely, and of course every die is going to leak. However, the configuration of the tool and certainly has a lot to play in that leakage. For instance, the multiple slides can pose a problem. Now, we do have customers that use seals on their tools to increase or decrease the amount of leakage that they would experience. But as a general rule, just running dies, our experience has shown anywhere from 14 to 22 inches of mercury are probably good numbers that you could anticipate, when you're running. Like I say, it's such an individual case by let's say the parting line configuration. Also has a lot to do with how the tool is constructed and actually the way you've designed the vacuum system itself. And when I say that, I'm talking about the internal design of the outlets and so forth. So it's a pretty broad question, but that's kind of that's been our experience as far as levels. Have levels been lower than that? Yes, it's possible to attain levels lower, but that's what we have right now as far as rules.
Right. Yeah, I think you hit it too, Blair. With it's going to be different for each each different die. And also you might find that a lower vacuum level might produce a good product. You're always going to have porosity no matter what, but the level of scrap, the percentage of scrap, what's acceptable with your customers, will kind of dictate also what the effect on the vacuum. So if you do have need a higher level of vacuum, that again might be particular on your specific die, if you need a higher vacuum level or not. So but like Larry indicated, that the 14 to 22 seems to be a level that we have experience with customers.
And that's easily attainable, I might add. So.
Perfect. Another question for the two of you, Larry and Bill. Are there any special tolerances required on the ejection pinholes?
No, I've never known any that I know that people have tried to pull vacuum through pins or to vent through pins, but no, there's no special tolerances between the pin and the hole.
Right. We've had cases where we've actually put ejector pinholes within the vacuum block, and at times customers may have a secondary bushing that they'll press into the block to give a tight, more of a tight tolerance on the direction and the where the ejector pin is at. But I think your standard tolerances on pins going into bushings or into a tight area, it kind of, there's kind of a wide variety of what we have seen in the past.
Yeah, the other thing I might add is if the vacuum level, and I don't even know if I've ever seen it, but it's possible if you're lubricating your pins, maybe that's what they're leading to, that would it be possible to pull that lubricant into the tool? Possibly, but at that point it's kind of a mute because it's beyond the, and I'm referring to now in the block or in the, that's a vacuum block itself, or in the outlet runner vacuum system. There you don't really care if you're pulling, if you're pulling, but I can't think of any instances. The only instance I've ever seen with too high a vacuum was in fixer molding, where the plug was actually pulled right out of the nozzle, if anybody's familiar with Fixo. And that in that instance, we had to reduce the vacuum level.
Alrighty, I'm not seeing any more questions at this time. Mark, any last thoughts or words here?
No, again, we appreciate everybody's time today, and as I mentioned earlier, we're interested in having anybody test out the system if they're interested in doing so. Again, we'll have product, whether it's demo units or product to purchase, ready by early to mid-June. And again, we've got our next webinar coming up on June 23rd. And don't forget to follow us on LinkedIn as well for future updates from Midland Technology.
Great. Once again, thank you everybody for joining us on this webinar, and we look forward to seeing you here in June.